It's no secret I like fractals. Well, visually at least, and in some cases as video games. But what do fractals sound like? I mean, it's pretty obvious they taste good, but listening to them?
Is
The Mandelbrot set.
an instrument?
No, Patrick,
The Mandelbrot set.
this is not an instrument.
Or is it? So real quick, I know this isn't a Hyperbolica devlog. This was just an idea I had, and I was just so curious about it, I had to try it. So I coded up a quick prototype in just a couple hours. Now, in order to explain the instrument I'm about to show you, I need to first quickly explain what the Mandelbrot set really is. Most people know it as the following. You take any point C on the complex plane, make a copy of it, call it Z, and then just keep updating Z with this equation thousands of times. If the point eventually drifts off to infinity, it's not part of the set, and gets assigned a color. But if it converges, or goes into a cycle or something, then it is part of the set, and we color it black. Note that you don't actually need to use or even understand complex numbers. Regular old x and y work too. It just makes the equation look less elegant. But what is the path each point takes as it iterates? Well, here I can actually show how that looks. Depending on which point you start with, it will either converge to a point, escape to infinity, or converge to a cycle called an orbit. These orbits can have different periods, like 3 or 4 or 5, and different shapes by just choosing different points. And so all this interesting structure and nuance is lost when we just color it black. And it got me thinking, what if we treat these orbits as sound waves? Then I could listen to different parts of the Mandelbrot set and hear how they sound. So the way this works is basically I just convert the x and y coordinates to the amplitude of the left and right speakers. I choose a low sampling rate like 8 kHz and use some interpolation to smooth it to a more standard 48 kHz. Now it's really easy to tell the period of the orbit because you can hear the fundamental frequencies. Another neat thing is that as you zoom in, each bulb adds another harmonic on top of the original one, depending on which bulb you choose. Oh yeah, and you can't zoom in too far, because this all runs on the GPU in real time, so that means it has a limited precision. Also, these pure tones are kind of annoying, so I'm going to add some dampening to make it more like an instrument. Although it's really fun to play around with, the problem with the Mandelbrot set is that all the interesting chaotic areas are unstable. So you could never actually click on them because you'd need infinite precision. So the orbit will always converge to some kind of repeating pattern, which will just sound like a combination of pure tones. If we want to hear some more interesting sounds, we have to switch to some different fractals. This one is called the burning ship fractal, because that's exactly what it looks like over here. The nice thing about this fractal is that it has chaotic regions that are actually stable, and some sound really creepy. It's still a little hard to tell what's going on when the fractal is entirely black, so I'll add some coloring based on the orbit. There's regions that converge to a point, to a cycle, and to chaos in different ways. Speaking of fractal variants, here's one that I came up with that I call a feather fractal. There's a few reasons I like it. First of all, there's a ton of good clusters everywhere that have different notes to play. So it feels much more like some kind of infinite piano where you can zoom in and find all sorts of different notes with different tonal relations. The other reason I like it is that it just looks so cool. I mean, look how beautiful this is. Now let's switch from beautiful to ugly again. This fractal I'm calling the sound effects fractal. It doesn't look like much, but it has an extreme variety of sound effects it can make because the orbits have a really interesting symmetry. Looking at the orbit colors reveals a really rich and complicated structure, which shows why there's so many sounds it can make. It reminds me a lot of those SFXR programs that are used a lot in game jams, and I'm pretty sure this fractal one could be useful for that too. If you're familiar with fractals already, you may be wondering, what about the Julia sets? Well, the reason I didn't mention them is because they're usually really boring, at least in terms of audio. For the Mandelbrot set, any point on the Julia set will converge to exactly the same orbit as the point corresponding on the Mandelbrot set. Now, some other fractals can behave a little differently. For example, there's some Julia sets of the Burning Ship fractal that are bistable. A single Julia set can converge to one of two orbits depending on the starting point. And if you want to get even more exotic, I found that some chaotic maps, such as the Chirikov map, do actually have continuums for the Julia orbits. Anyway, this whole program is available on my itch.io page, and the source code is on my GitHub. Honestly, it's easy to waste hours just exploring and finding new sounds, so check it out, and don't worry, I'll be back with more Hyperbolica stuff soon.